As you continue looking at chemical reactions, one of the things that you should be able to do is start to recognize the difference in the types of reactions. They're not all the same. You can tell that as you've been looking at them, but we're going to look at some key things that will help you to figure out how to balance the reactions and figure out what kind of reaction is taking place. So we're going to look for patterns. And those patterns are going to help us to identify the kinds of reactions. And in chemistry, we'll take it a step further and also be able to predict the products of the chemical reactions. So we start with the first kind of reaction. It's called a synthesis reaction. You've probably heard synthesis before in biology, photosynthesis. Synthesis reactions combine substances. So we would define it as a reaction in which two or more substances combine to form a new compound. Generally speaking, what we're looking at is multiple reactants and often a single product. Not always, though. In photosynthesis, there's not a single product, but we'll look at how that's still synthesis anyway. But if we just start with our basic sodium and chlorine reacting to form sodium chloride, you can see that we have two elements combining to form a single compound. So if you're looking for a synthesis reaction, generally speaking, if you look at the product side of the reaction and there is only one product there, you have a synthesis reaction. So how can photosynthesis be a synthesis reaction? Well, as you learned in biology, 6CO2 plus 6H2O yields C6H12O6 plus 6O2. So we've got glucose being made and oxygen being released. Here's how it is a synthesis. We have carbon and oxygen in the carbon dioxide, hydrogen and oxygen in the water, and all three of them come together in the glucose. And then there's some extra leftover O2 that's released, but they have come together to make the glucose, and that's how that can be a synthesis reaction. The opposite of synthesis is decomposition. You know from life, when things decompose, they break apart or they rot, right? So if you're looking for a decomposition reaction, what you're looking for is a reaction in which a single compound breaks down to form two or more simpler substances. So it may or may not break apart into its individual elements, but it is a compound that breaks down into more than one thing. So they have the general form of the compound AB forming A plus B. Water goes through decomposition in electrolysis. So water, H2O, can be broken down to be hydrogen gas and oxygen gas. And we do see that happening in this example. This is electrolysis. Electrolysis, from the root of electrolysis, you get electricity, right? So it requires electricity as the energy source in order to make this happen. But when there is water in these two flasks or these two tubes, and you introduce an electric current, the water actually separates into hydrogen gas and oxygen gas. And just another simplified version of that. The third type of reaction is a combustion reaction. I think if you, again, think about your everyday life, you in general know what combustion is. We know that combustion means burning or fire. Inside of your car engine, an internal combustion happens. Combustion always requires oxygen as a reactant. So what is happening in a combustion reaction is the oxidation of an organic compound, and heat is always released. So heat is going to mean that it's an exothermic reaction, and that's our experience with combustion, isn't it? That if we burn something, that we're going to release heat in the process. When you look at the product side of a combustion reaction, you will see water as a product and carbon dioxide as the other product. Now those are complete combustion reactions. Sometimes, if there isn't enough oxygen available, we have incomplete combustion. This happens and we don't always get carbon dioxide alone. Sometimes with it we get unburned carbon, or we may even get carbon monoxide. And some of you may be familiar with the concept of carbon monoxide poisoning, right? When a car is not getting enough oxygen, when it burns its fuel, it may give off carbon monoxide as a fume out of the muffler. The problem, of course, with that is when you are exposed to carbon monoxide, it is a colorless, odorless gas, and you may not even realize that you are being exposed to it. And it can be deadly. So that's why we never run an automobile in a garage with the door shut, because that carbon monoxide can build up. It's also the reason why you should have a carbon monoxide detector in your home if you have a furnace that is heated by gas, because as the furnace starts to get older and wear out, it is possible, doesn't always happen, but it is possible that it quits burning the carbon or the gas completely. And so there isn't enough oxygen there for it to burn it completely. And carbon monoxide can be produced and released into your home. And of course, that's a bad situation. So if there's not enough oxygen, then not all of the fuel is converted into water and carbon dioxide. It would look something like this. We can see on the reactant side, we have a carbon-hydrogen compound, and we have oxygen. And on the product side, we have CO2 and H2O. For our purposes, we're going to assume complete combustion always. We're going to just simplify it. So we're just going to assume that if a carbon compound burns in the presence of oxygen, that carbon dioxide and water are going to be the products. This is one of the balancing equation tricks that I talked about. Remember, I said that if you are balancing this, and you are going to multiply by an odd to do the h's, that you would double it, and if you're going to multiply by an even, you wouldn't need to. Now if you take a look at this example, there actually is a problem in this example. They are showing 2 of the methanes, 4 oxygens, 2 carbon dioxides, and 4 waters. And in fashion, just like when you write chemical formulas for ionic compounds, if it can be reduced, it should be reduced. So in this case, it should be, instead of 2CH4, it should just be CH4 plus 2O2, making CO2 plus 2H2O. In other words, all of these coefficients are divisible by 2 and should be reduced.